Once you're in StatCrunch, you're going to go ahead and click Applets, and then you want to do confidence intervals. And we are talking about proportions currently. You'll need to change the proportion to match the problem. We're going to say 0.12. And then we also want to change the confidence level. So if we're going to do, let's say 95% or 90%, we would do that down below where it says initial confidence level. And then ask for initial sample size. Let's go ahead and let's do 100 and compute. So what you'll see here is 100 intervals. On the left-hand side, you can see the values. The red means that the proportion was not captured in the interval. So at the top, we've got 5 didn't have it, 8 didn't have it, 47 didn't, 78, and 92. So 5 of the 100 intervals that were created did not capture the proportions. The black line that you see on your diagram is the true population value of 0.12, and then the computer takes a proportion and says, okay, let's go ahead and both pull from a sample, calculate that proportion, and then see whether, using the margin of error, whether proportion would be captured or not. And we see that 95 out of 100 were captured. So we did hit our 95 out of 100, but let's do 1,000 intervals. Well, 1,000 intervals, at this top bar, you see 0.95. There were there was 1,026 contained P out of a total 1,100, which means that we captured 93% of the proportion, the population proportion. So the 95% does not guarantee that we're going to capture the population proportion. It's just on average what we estimate. Let's do another 1,000. Oh, we got to 94.48. Another 1,000, 94.28. So notice that some of our proportions are capturing and not, but we're sticking really around that 95% as we would think. Now we're going to calculate a confidence interval, and then we're going to answer whether something is likely or not and whether our values are unusual or not. Now, cesarean sections in 2010 had a proportion of 32.8%. So the population average was 0.328. Now, we took a sample of size 100 and determined that 41 out of 100, which is our p hat or our sample proportion, had C-sections. We want to create a 95% confidence interval, and always we want to check the normal model. There's actually three conditions you should be checking. You should be checking whether you're talking about a random sample, whether your sample is independent, and whether it is normal. And by independent, you're determining whether one woman's cesarean section affects another, which it doesn't clearly. So our condition or our sample is independent. But these are some things that when you're doing in actual statistics, you're tasked with checking more than just the normal condition. Remember that the normal condition is checked by NP greater than or equal to 10 and N1 minus P greater than or equal to 10. Our sample size is 100. We're using 0.328. That means we have 32.8, which is in fact greater than 10. And then we have 100 times 1 minus 0.328, which gets us 67.2. which is also greater than 10. So we can use the normal condition. We can go ahead and perform calculations. Now remember, in order to calculate our confidence interval, we need our statistic plus or minus the margin of error, which if we're talking about 95% is 2 times the standard error. And we need that standard error or standard deviation that we're going to use. We're going to take the standard deviation of the sampling distribution is equal to the square root of P times 1 minus P over N. That's the square root of 0.328 times 1 minus 0.328 divided by the sample size of 100. 0.41 plus or minus 2 times 0.0469 gives us an interval of 0.3162 to 0.5038. So between 31.6 and 50.3% would capture the true cesarean section rate 95% of the time. Okay, well, what about the learn by doing on page 28 that asks whether something's likely or not? What we want to know is, is the percentage lower this year? This is the question that we're answering. So with the data, they claim that an estimated 20% smoke. The population has a value of 20%, and they want to know whether it's lower this year. We select a random sample of 100 adults, 18 or older. This means that the normal condition has been met because we have 100 times 0.2, which is 20. So we expect 20 smokers, which means that we're going to have 80 non-smokers. And those are both greater than 10. Now, we're going to use a z-score and a standard normal curve to assess the evidence, and we suppose that 15 of our 100 in the sample are smokers. So we have an actual value of 0.15 for our p-hat. Using a z-score, remember, it's the value minus the mean over the standard deviation, which can also be seen as a standard error. So this translates to p-hat minus p over p1 minus p over n for our situation. We have the sampling distribution value of 0.15, the population value of 0.12, and then the standard error of 0.04, which is given to us right here, which we can actually calculate again by taking square root of 0.2, 1 minus 0.2 over 100. This gives us a z-value of negative 1.25. Now, remember your normal distribution? Around our proportion, one standard deviation gathers 68%, two standard deviations captures 95%. Well, where would minus 1.25 be? In your standard normal curve, you have a z-score of 1, 2, 3, negative 1, negative 2, negative 3. Negative 1.25 would be right in here. That's in between 68 and 95%. That's not unusual at all. This would say, no, it is not unusual. And if you remember back a ways, we used 5% as our measuring stick of whether something was unusual or not. And the probability, if you use your normal calculator on StatCrunch of negative 1.25, you would find that it is not unusual at all. Okay, lastly, the data that we have here estimated 9.45% of US children have asthma, and they want to know if the percentage has lowered. We have a random sample of 50. So this is P equals 0.094, random sample of 50, and then our proportion is 3 out of 50. Well, the conditions aren't met because we're not, our NP and 1 minus P are not greater than or equal to 10. That fails. And so what we've done here is we've created a simulation to see how many times we would get the same results. And we got the same results 28.9%, which is not rare. Again, 5% is our barometer. So if we found something that was less than 5%, we would say, yes, it's rare. But 28% is not rare. 5% or less is unusual. So we would say, no, the percentage is not lower. And that's all I have for you.